All right, let's go ahead and do some examples. First examples, we're going to go ahead and decide before we follow any of the other directions. Let's just start this first part. Oops, I want the highlighter. We want to determine which of these are actually polynomials. Okay, biggest thing you're looking out for is you want to make sure there isn't a term that has a negative exponent or like a fractional exponent. So -8 seems like it's not a polynomial, but fun fact, it is. Your variable is just x to the 0 power. So, and 0 is still a non-negative integer. Okay, so that one's good. So this is a polynomial. These ones, we've got x squared, we've got x to the 99th, x to the 1st. That all looks good. The other thing you're looking out for is just making sure the numbers in front are real numbers. So basically you just don't want imaginary numbers, so we're good there. Okay, so no I. This term though right here, square root of x, is actually the same thing as x to the 1/2. So since this is a fractional exponent, that means this is actually not a polynomial. So really just watch out for those exponents. That's the biggest thing you're going to be looking out for. Okay, so let's go back to these other two. They want us to go ahead and state the degree, the maximum number of turning points, and the end behavior for each one of these. So let's go to this -8. This one's kind of a tricky one. Degree, once again, if you put a variable in there, x to the 0 is 1. So our degree is actually 1. Or sorry, not 1. It's 0, because it's our highest exponent is 0. End behavior is going to be different than most of the other ones, and that's because if you graph y equals -8, that's just going to be a straight line, right? A horizontal line. So your end behavior literally is just, we're just going to go ahead and put an arrow like that. If we wrote it out officially, which I'm not requiring you to do, you would say as x approaches -infinity, y is going to be 8, right? So, or sorry, -8. But I don't need you to do that. You could do the other side as well. You can just draw a picture that says, oh, well, the arrows are just going to be going constant on both sides. Let's get to something a little more exciting. Oh, maximum number of turning points. If the degree is 0, you can't have a negative turning point, so it's still 0. So let's go to one that's a little more exciting. So the second example right here, our degree is 99, because it's the highest exponent. Maximum number of turning points then means there's going to be 98, because it's 1 less. And then end behavior. So this is how I like to think of it. I look at, so you can use the little chart I have over here, which I'll show in a second. Or you can just look at this term. The sign of the first number, so the sign of the coefficient, will actually tell you the left or the right arrow. You always choose the right? So right side, since it's negative, is going to be going down. The degree is going to tell you if your left side is going to do the opposite or if it's going to stay the same. So odd degrees always go the opposite direction. But you could also use the little chart I gave you. So we have a negative leading coefficient with an odd degree right here. So that tells us it goes up, down if you follow the chart. So that would be your answer. Let's do a few more of these. Okay, so this problem right here is tricky. A lot of people think, oh, the exponent is 1, when in fact, if you rewrite this, it would be a -1. Therefore, this is not a polynomial. Oops, there we go. So we're just done with that one. So if the variable's on the bottom of if it's in the denominator, it's not a polynomial. So this next one, there's no variable on the bottom, there's just a 2. So it's actually still a polynomial. So let's go ahead and state our degree. So degree is the highest exponent, so that is 2, which means our maximum number of turning points would be 1 less than that, so 1. And then in behavior, once again, you can use the chart or just choose the right method. So our first number is, or the leading coefficient is positive, which means the right arrow will go up. And then the degree is even, which means they're going to go the same direction, so the other one's also going to go up. And then Let's go to our last one. So on our last one, once again, it's actually still a polynomial. Just because there's a pi in here, that pi is still a real number. It's not imaginary. So we're good to go. All the exponents are, all the exponents, there we go, are integers, so we're good there. So we can go ahead and say our degree is our highest exponent, which is 3, which means our maximum number of turning points is 2. And then end behavior, since the leading coefficient is positive, the arrow is going to go up. Since the degree is odd, that means they're going to switch directions just like a cubic, so it'll be down up. And we can just keep going. I'll just do a few more. You don't have to watch these anymore if you don't want to. This one, since this is a fractional exponent, it is not a polynomial. Just like that. While this last one, there are no fractional exponents, we're good. So once again, degree is the highest exponent. Maximum number of turning points is 1 less than degree, so 13. And then end behavior, you look at the leading coefficient of the term, so negative 10. So it's negative, which means our right arrow is going to go down. And since the degree is even, they're both going to go the same direction, just like quadratics go the same direction. So it's also down.